In this lesson, we're going to be looking at probability, and we're going to use the definition of probability to find the probability of a given event. In order to understand this lesson, we need to know some definitions. An experiment is an activity in which results are observed. Each observation is called a trial, and each result is called an outcome. The sample space is the set of all possible outcomes of an experiment. Yesterday we flipped a penny, so that's what the experiment was, determining how many times it's going to land on heads or tails. Each time we flipped the penny, it was called a trial, and when we recorded the result, that was an outcome. It was either heads or it was tails, and the sample space is heads or tails. That's two possible outcomes. You can see other examples of an experiment would be rolling a number cube. We call that a dice, and the standard dice has 6 sides, numbered 1, 2, 3, 4, 5, and 6. Or we could look at a jar of marbles or a can of pencils, and we can guess how many are in there, and that would be a whole number. An event is any set of one or more outcomes, and the probability of an event is a number from 0 to 1 or 0% to 100%, and it tells you how likely the event is to happen. P parentheses event, that's the probability of the event occurring. If you get a probability of 0, it means the event is impossible and it can never happen. A probability of 1 means the event is certain and it will happen. If we're talking about the probabilities of all the outcomes, the probabilities add up to 1. An example of that would be flipping a coin. There are 2 possible outcomes, so when you flip the coin, you're going to get one of the 2 possibilities. So one of the 2 possibilities is heads, 1 out of 2 of the other possibilities is tails. So it would be 1/2 and 1/2. If we added those together, it would be 1 or 100%. This chart gives you an idea of how likely something is to happen. If it's 0, it never happens. If it's 100%, it always happens. 0.5 or 50% happens about half the time. And 75% would be likely to happen, and 25% would be not likely to happen. If a basketball team has a 70% chance of winning, that means they have a 30% chance of losing. Looking at the probability of getting a 1, a 2, or a 3, the first thing we need to know is how many possible outcomes there are. There are 1, 2, 3, 4, 5, 6, 7, 8 possibilities, and there are 3 ones. So the probability of getting a 1 is 3 out of 8. The probability of getting a 2 is 3 out of 8. And the probability of getting a 3 is 2 out of 8, or 1/4. If I add up all 3 of these probabilities, it will equal 1. And we can also convert these fractions into percents. So 3 out of 8 is the probability of getting a 1 on the spinner, and as a percent it would be 37.5%. The probability of getting a 2 would be 37.5%, and the probability of getting a 3 would be 25%. If a polo team has a 50% chance of winning, they also have a 50% chance of losing. Remember that the probabilities have to add up to 1 or 100%. In this example, we're looking at the probability of rolling each of the numbers on a dice, and each of these numbers are equally likely, so they all have a probability of 1/6. And 1/6 as a percent is 16.6 repeating, so we're going to say 16.7% for all of these probabilities, these outcomes. If we're looking at the probability of multiple events, we'll add each of the individual probabilities. An example of that would be the previous page where we had 1/6 as a probability of getting a 1, a 2, a 3, a 4, a 5, or a 6. And what's the probability of getting a 1 or a 2? We would add the 1/6 and the 1/6 for a total of 2/6, which would simplify down to 1/3 or 33.3%. So in this one, what's the probability of guessing 3 or more correct? So 3 or more. It's going to be 3, 4, and 5. So we add up those numbers. And we get 0.500 or 50%. So we have a 50% chance of guessing 3, 4, or 5 correct. So what's the probability of guessing 2 or more correct? So it would be 2 plus 3 plus 4 plus 5. We already added 3, 4, and 5, so we know that's 50%. So we're going to add 2 to it, and we get 0.813 or 81.3%. Now it wants to know what's the probability of passing the quiz by getting 4 or 5 correct, and that would be 0.156 plus 0.031. So 18.7% chance of passing a true-false quiz by guessing. I think I would study. Okay, it's another probability problem here. We've just put it in a story problem because we're talking about a race and we want to figure out who has the best probability of winning. So it says create a table of probabilities. So we want to find out, first of all, who's racing. We have Ken, we have Lee, we have Roy, and then we have Tracy, James, and Kadeem. Alright, so now all of these numbers, all of these probabilities have to add up to 1. So Ken's probability of winning is 0.2. So Ken was here. This is Kadeem at the end. Lee is twice as likely to win as Ken. So twice of 20% is 40% or 0.4. Roy is 1/4 as likely to win as Lee. So 1/4 times 0.4 or 1/4 times 40% is 10% or 0.1. And the last three all have the same probability of winning. So these numbers at the end have to be the same. We add up what we have already. 0.2 plus 0.4 plus 0.1 is 70%, 0.7 or 70%, which means the remaining three have a 30% chance of winning. Divide that evenly. 30% divided by 3 is 10% each, or 0.1.